Close your eyes for a moment. Place your hand on your chest. Feel that? That steady rhythm? Your heartbeat, about 70 beats per minute. It's the soundtrack of your life, marking time from your first moment to your last. Now imagine a heartbeat that lasts not seconds, but days. Or years, or mere minutes. Imagine a heart so massive that Earth could fit inside it 1,000,000 times over. These are the heartbeats of stars, stellar pulsations, and tonight I want to share with you how listening to these cosmic rhythms has revolutionized our understanding of the universe and our place within it. My fascination with stellar pulsations began on a cold night in graduate school. I was observing what I thought was an ordinary star when I noticed something odd. Over the course of hours, this pinpoint of light was breathing, getting brighter, then dimmer, then brighter again, like a lighthouse in the cosmic ocean. What I didn't realize that night was that I was witnessing something that would transform astronomy. The star was pulsating, expanding and contracting like a giant spherical lung, and encoded in that rhythm was information about the star's deepest secrets. But let me back up. Why should you care about pulsating stars? Think about how we understand people. We can learn something from appearance, height, approximate age, maybe mood. But to truly know someone, we need to see inside. We need X-rays to see bones, MRIs to see soft tissue, EKGs to check heart health. For most of human history, stars were just points of light. We could measure their brightness, their color, even their chemical composition. But their interiors? Complete mysteries. It would be like trying to understand human health by only looking at skin. That changed with the discovery of stellar pulsations. Here's the beautiful part. Stars that pulsate are essentially ringing like bells. Just as a bell's tone tells you about its size, shape, and what it's made of, a star's pulsation tells us about its interior structure. Let me play you something. What you're hearing is real data from a pulsating star, sped up about 1,000,000 times. Each star has its own voice, its own cosmic fingerprint. And by listening carefully, we can determine incredible things. How massive is the star? How old? What's happening in its core, where temperatures reach millions of degrees? We call ourselves astroseismologists, star seismologists. Just as seismologists use earthquakes to map Earth's interior, we use these stellar vibrations to peer inside stars. It's like doing an ultrasound on a star 100 light-years away. And here's where it gets mind-blowing. Some stars pulsate in dozens, even hundreds of different modes simultaneously. Imagine a bell ringing with 100 different tones at once, each tone telling us about a different layer of the star. Using just the light from these stars, photons that traveled for centuries across space, we can measure the size of a star's core to within 1%. We can detect magnetic fields buried deep inside. We can even measure how fast different layers rotate, like cosmic MRI scans. The game changer came with space telescopes. From space, without Earth's atmosphere interfering, we could detect pulsations so subtle they change a star's brightness by just a few parts per million. That's like detecting the light change when someone 3,000 miles away lights a single candle. Suddenly, we weren't studying dozens of pulsating stars. We were studying thousands, then tens of thousands. each one a laboratory for understanding stellar physics. Let me share 3 discoveries that still give me goosebumps. First, we discovered that stars have birthmarks. By measuring pulsations in young star clusters, we found that stars remember the conditions of their birth billions of years later. The turbulence of their stellar nursery is frozen into their pulsation patterns like a cosmic fingerprint. Second, we caught stars in the act of dying. When stars like our sun age, they develop what I call stellar dementia. Their cores become incredibly dense, while their outer layers expand enormously. We discovered that in these dying stars, the core spins 10 times faster than the surface. Imagine Earth's core completing a full rotation while the surface has only moved from morning to noon. Third, we solved a cosmic mystery that plagued Einstein himself. How do we measure the universe? For decades, astronomers argued about cosmic distances. Were galaxies millions or billions of light years away? Einstein couldn't complete his cosmological models without knowing. Pulsating stars called Cephids became our cosmic measuring tape. Their pulsation periods directly relate to their true brightness. By comparing how bright they appear to how bright they actually are, we can measure distances across the universe. These stellar heartbeats helped us discover that the universe is expanding, and even more shocking, that expansion is accelerating. But here's the moment that changed everything for me personally. 5 years ago, we pointed our instruments at the most important star of all, our sun, and we heard it singing. The sun pulsates too, just very gently. And hidden in those tiny pulsations, we made a disturbing discovery. The sun's core, where nuclear fusion creates the energy that keeps us alive, is rotating slower than our models predicted. This tiny detail, discovered through stellar pulsations, forced us to rewrite our understanding of how stars transport energy and angular momentum. If we were wrong about our own star, what else had we missed? This brings me to why stellar pulsations matter to all of us. Stars aren't just distant lights, they're our cosmic ancestors. Every atom in your body, except hydrogen, was forged inside a star. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now, all of it was created in stellar cores and distributed through the universe when those stars died. By studying stellar pulsations, we're not just doing abstract science, we're reading our family history. We're understanding how the universe created the conditions for us to exist. But here's the twist that nobody saw coming. The mathematical techniques we developed to analyze stellar pulsations? They're now being used in medicine. The same algorithms that decode a star's interior are helping doctors detect heart irregularities earlier. The same physics that explains why stars pulsate is improving ultrasound imaging. We reached for the stars and ended up helping humanity in ways we never imagined. We're now on the verge of something extraordinary. New telescopes coming online will let us detect pulsations in stars across our entire galaxy. We'll go from studying thousands of stars to millions. It's like going from hearing a solo violin to experiencing a full cosmic symphony. And hidden in that symphony are answers to humanity's deepest questions. How do stars create the elements of life? Are we alone? How much time does our sun have left? But more than that, stellar pulsations teach us something profound about existence itself. Everything in the universe, from the smallest atom to the largest star, vibrates, oscillates, pulses. We are part of a cosmic rhythm that's been playing for 13.8 billion years. Remember that heartbeat you felt at the beginning? Here's the beautiful truth. You are more connected to the stars than you ever imagined. Not just because you're made of star stuff, but because you pulse with the same fundamental physics that makes stars breathe. Your heartbeat, roughly once per second. The sun's gentle oscillation, once every 5 minutes. A Cepheid variable's pulsation, once every few days. Different scales, same cosmic dance. So tonight, when you walk outside, I want you to look up. Those points of light aren't static. They're alive with motion, ringing with vibrations that carry the secrets of the universe. And now you know how to listen. Every time you feel your pulse, remember, you're feeling an echo of the same forces that make stars shine and galaxies form. You're not just in the universe. You are the universe, contemplating itself. We started as a species looking up at the stars and making up stories about heroes and monsters. Now, we listen to their heartbeats and decode their life stories. We've become the universe's physicians, taking its pulse, monitoring its health, understanding its future. And in learning to hear the heartbeat of stars, we've discovered something magnificent. The universe isn't just vast and cold and empty. It's alive, it pulses, it breathes. And so do you. Thank you.